Good
Let
morning,
me
everyone.
remind you that time duration is 30 minutes maximum.
Yes, sir.
Please go ahead.
Okay. Good morning, everyone. We are Lactea. My name is Dikshit Pinaya, and I'll be doing the introduction. So today, in our project next, we'll be explaining about how we are going to build our space station. A question may arise in our mind: why the name Nyx? Nyx means the Greek goddess of night sky, and Nyx is going to help us to guide and explore the outer space. Next. So, what is a space station? A space station is an artificial modular satellite structure which is a habitat in space. In our mission, we have taken up the challenge to build up a space station in the orbit. Today, in our presentation, we will be going through all these topics.
Good morning. My name is Christian Mariano Rosario. I'm here to talk about the facilities incorporated into NICS to support habitat and healthcare. NICS will be made of multiple pressurized modules that allows people to pass from one module to another without facing any problems. The crew members will only be sent to the space station when it's completely operational and the pressure inside the space station is stable. So the next, to ensure that the people inside the space station are fed well, NICS is equipped with a specific module that stores food for everyone aboard. The module is replenished periodically by using the supplies brought in by the spacecraft used for space tourism and other spacecrafts. The other habitat issue that we face is waste management. The main waste that requires disposal are human excreta, which will be collected by a cargo spacecraft and burned upon re-entry. The recyclable waste will be recycled and used appropriately for basic needs. A specific healthcare module is installed in the space station to keep track of all health-related issues faced by the people in the station. The healthcare module is equipped with a gym, which uses advanced resistivity exercising equipment to ensure that everyone aboard the station would stay healthy.
Preliminary sizing. Under preliminary sizing, we are covering two topics: crew capacity and the shape and volume of the modules. Crew capacity. The space station is provided with two crew quarters which can accommodate up to 12 members. That is, 6 members in each crew quarter. Every crew quarter is provided with all the essential that is necessary for the survival of these 12 members. Shape and volume of modules. The space station is built using small structure units called modules. Each module differ in shape and size. The main modules that are used in the space station are the CM01. It is the controlling module of the space station. We can call it as the brain of the space station. It consists of the main components like navigation, communication, and the controlling monitors. As it is, all these things are included in the controlling unit, it has a very large volume. The PDM01 is a passage docking module that has 5 docking ports, 2 in the rear ends and 3 in the lateral surface area. Docking port is provided for the further expansion of our space station. The integrated truss is the power production plant of our space station. The integrated truss will be provided with solar panels, radiance, and nuclear power reactors for continuously producing energy and supplying it to our space station. The food management module, as the name itself, will carry the food for the astronauts. The experimental modules will be the modules where the experiment will be carried out by the astronauts. The airlock cabin, it will be used for going out of the space station and coming to the space station from space. The centric recorder will be the place where the astronauts will be staying. The Space Observatory Telescope will be used for observing outer space.
Amrita Vihar, and accompanying me is Addison Najos. We're going to talk about environmental and life support systems. So let's control. Hazard control is more like a safety measure to reduce the threat faced by the astronauts. Hazard control mainly includes damage control, containment, isolation of potential hazards, incorporation of safety devices, crew operational procedures, protective clothing and equipment. Now, to meet these safety requirements, we have some methods. Each module is made from aluminum and composite fiber reinforced plastic sandwich material, which is again covered with a coating of a wolverine material. Aluminum and composite fibers acts as a double-layered protective barrier, and the wolverine material has the ability to stretch twice its size within a 5-minute time limit. Thus, in case of a minor damage, the wolverine material can heal itself. As part of emergency measures, escape pods are set up. Carbon dioxide fire extinguishers are installed in case fire breaks out. Nuclear reactors are placed on the main control system, which can be detached if necessary. Now, about breathable air and water sources and how it can be reused. To access water in space, we have a mechanism called the Sabatier reaction. The urine from the crew is filtered to produce water, which is made to undergo electrolysis. The hydrogen produced from this electrolysis is reacted with carbon dioxide, which is released by the crewmates during respiration. This leads to the release of water and methane. This water is drinkable, and the methane is used for refuel in incoming rockets. The oxygen produced from electrolysis is later used for breathing purposes. Now, about spacesuits. There are different types of spacesuit, but the main one used would be the EVA suits, which is used for spacewalk and exploration. The first piece worn is a cooling garment, which is actually a special clothing made of spandex material and water tubes. Chilled water runs through the tubes, which help to regulate temperature. Even vents are made so that it can draw away the sweat from the astronaut's body. A lightweight upper torso is worn, which is equipped with many life support systems. Special gloves are worn, which can allow them to move their fingers freely. Heaters are installed so that they can keep their fingers warm. The lower part consists of special pants, boots, and lower waist. This waist helps them to turn and move easily. The suit is actually made of 16 layers, where each layer has its own function. There are tear-resistant, insulating, water-resistant, bulletproof, and even fire-resistant layers. On the back of the suit, there is a backpack where life support systems are placed. The pack also pressurizes the whole suit. It contains oxygen and the cooling systems. Integrated audio systems are also installed for communication. Astronauts walk frequently from pressurized module out into the space, usually for space experiments or other purposes. This is where airlocks come in. Airlocks are small compartments which help to move in and out through two different pressurized areas. Airlocks are placed in such a way that it can be used for three main purposes: tourism, servicing of spacecrafts, and outdoor experiments. Now, Addis.
Discuss about thermal protection and humidity control. Thermal control system helps to maintain the temperature of space station within a particular range. In space, excess heat produced by sources such as instruments, heaters are removed by radiators. There are two types of systems, passive and active. Active thermal control system involves mechanical moving parts of fluids, whereas passive thermal control system does not involve them. Under passive thermal system, we have surface coating and multi-layer insulation. Surface coating. A chemical called Z93 is applied to the surface of the space station, which has high emissivity and low absorption property to radiate excess heat to space. Multi-layer insulation. It helps to prevent both heat loss to the environment and excessive heating from the environment. The space station is covered with MLI to thermally isolate the interior of the space station from space. Space components are also covered in MLI to maintain ideal operating temperature. In thermal control system, we have heat pipes, thermal heaters, and lumens. Heat pipes. Heat pipes are closed two-phase liquid flow. First phase contains cold water, which runs throughout the space station. The cold water absorbs heat and carries it to the second phase liquid, that is ammonia, with the help of a heat exchanger. Ammonia further carries the heat along the thrush to the radiators. Here, radiators are made up of honeycomb aluminum panels. Thermal heaters. They are used in cold environments to warm up components to their operating temperature and are controlled by a temperature sensor. Captain heaters are used here. Lures. Lures are those active thermal control elements who can change the area of radiating surface depending upon the amount of radiating heat. A lure can reject 6 times heat in open state when compared to complete closed state. Humidity control. If you want to reduce the temperature of air, the air is passed over cooling layers. And to increase the temperature, the air is mixed with warmer air. Personal hygiene equipment. Crewmates also need to maintain their personal hygiene. Each astronauts have their own personal hygiene kit. Toothbrushing. Since we have limited water supply, astronauts use edible toothpicks that can be swallowed after brushing. Taking shower. They take short sponge baths with special rinseless soaps and shampoos. Bathroom. Space toilets work like a vacuum cleaner which sucks waste into the pump. Later, the human waste is separated. Solid waste are compressed and the urine is recycled. Urine by both men and women are utilized by a hose. Each astronauts have their own personal urinal funnel that can be attached to the hose. That's it.
Now about energy harvesting and management. The first energy source that comes to our mind is solar energy. Yes, as said before, the space station is placed in the low Earth orbit, which exposes it to the direct sunlight more than half of its course around the planet. The space station will be using hybrid perovskite and organic photovoltaic, also known as HOPV. These HOPVs have high resistance that can withstand the extremities in space, such as microgravity, AM0 solar radiations, cosmic particle radiation, high temperature fluctuations, and ultra high vacuum. The HOPVs used in space station will be attached to aluminum rods of length 24 meters containing two solar plates with a total length of 24 meter and breadth 5 meter, giving a total area of 120 meter square per array when unfolded in space. Solar panels will be attached to aluminum rods by layering them with extremely flexible and foldable ultra-thin lightweight polymer foils. The aluminum rods are attached to the module such a way that it can be rotated according to the position of the sun to increase its efficiency. The solar cells are used will be made of organic lead or tin halide based material. The absence of oxygen in space minimizes the degradation of solar cells, making them more reliable. Excess electricity obtained from the solar panels will be stored in lithium-ion batteries, which will be utilized to power the space station.
Is there an issue with your connection there?
Yeah, we're having a small issue with the PPT. Just
Yeah. We'll wait for that.
okay, sir. Okay.
I think now it's visible. You can
Relying-
carry on.
Yeah, okay. Thank you, sir. Relying on different energy sources is more safer and efficient. Hi, Devanand Raj here, and let's explore the next best source of energy: nuclear energy. Harnessing nuclear energy in space is also an efficient way to power our space station. The best way to harness nuclear energy in this station is by using micronuclear reactors. This station is equipped with two types of reactors: SNAP-10A and kilopower. SNAP-10A powers the ion thrusters used for propulsion. These reactors are powered by an isotope of uranium called U-235. This reactor has three main parts: a fission reactor that generates heat, an energy converter that transforms heat into electricity, a radiator that radiates heat that cannot be converted to further electricity. So, SNAP-10A has an estimated output of almost 30 kilowatt and an unshielded weight of 290 kilograms. So, it is easy for transportation. There are reflectors which reflects the escaping neutrons back into the reactor for maximum efficiency. Now for the next type of reactor, that is kilopower, with an estimated output of 15 kilowatt, fueled by uranium and molybdenum. The solar arrays, nuclear reactors, and power grids for this energy management are placed in the internet truss away from the modules for safety purposes. Excess electricity will be stored in lithium-ion batteries also present in ion truss. The grid system will regulate the voltage rating required for each deck. Now, let's dive into station keeping and propulsion. For locating the space station in low Earth orbit, this station is equipped with an efficient navigation system. Since the station is in low Earth orbit, it can have real-time communication with Earth. We use Global Navigation Satellite System, also known as GNSS. GNSS is a global widespread navigation system controlled by 6 constellations, which is mainly controlled by the European Union, Russia, US, China, India, and Japan. These widespread constellations can provide precise navigation and correct altitude. Galileo GPS receivers will also assist these GNSS constellations to enhance navigation of our space station NICS. GNSS uses the data compiled by existing GNSS satellites and analyze the data and send them to Earth as well as to the display computers aboard the space station. Now, let's move on to the main part of the space station. Now, just like the brain of a computer, the CPU, our NICS also has a brain called the Central Module 01, also known as CM01. So, the CM01 controls the entire working of the station, monitors health, controls the docking of the modules, and many other important works. The CM01 is the main hub for storing data gathered by the crew, contains the server for communication, navigation, and controls the main propulsion system. It also monitors the tourist activity in NICS. Now, for the next important part, NICS can't soar through the night sky without her. Just like that, we present you our propulsion system. Instead of using classic combustible engines, which are less efficient, NICS has ion thrusters. This propulsion system allows to keep the station in orbit at a certain latitude. Ion thrusters has an efficiency of 95%, and the material used as fuel is xenon. For an ion thruster to work efficiently, we require a power source, that is nuclear and solar energy, a power processing unit, propulsion management system, control computer, and ion thrusters. Here, as I told, the power source used is mainly nuclear energy from the SNAP-10A reactors. The electrical energy produced helps in the bombardment of electrons, which produces the thrust. The power processing units converts electrical energy into power required for each component. This thruster is equipped with cooling system and is continuously monitored by the programs to check its health. Now, about the propulsion management system. The propulsion management system provides a way for the xenon to expel into low gravity environment. The thrusters consume a power of 1 to 7 kilowatt, have an exhaust velocity of 20 to 50 kilometer per second, possess a thrust of 25 to 250 Newton meter, and an efficiency of almost 65 to 80%. Our station will have 5 thrusters, 2 placed in the rear end and 3 placed on the bottom end for altitude balancing. When in full throttle, these thrusters will produce a total speed of 1,620,000 km per hour. The reason why we chose xenon is because it has high ionization energy and low corrosive effect on the thrusters used for this propulsion system. Now, about the communication system. The crew members in this space station uses Internet Voice Distribution System. Our station is equipped with intranet servers working. IODS, which is Internet Voice Distribution System, has greater flexibility, coverage, and low maintenance cost. So we can perform any changes or alterations if necessary. IODS is equipped with administrator control. The admin control can control who will listen and converse in the communications done by the crew. The authorization personnel is provided with a personal desktop with a modem which has the capability to connect with the internet. The subsystem of the IODS contains conference servers, conference clients, administrator server, administrator client, virtual public network, telephone gateways, and NICS communication manager. And now for the communication between the crew members. Each of the crew members is equipped with an integrated audio system which is integrated into the spacesuit. With 4 microphone arrays placed near to their feet. This system is assisted with multi-channel noise reduction, which gives an excellent voice quality and suppresses the background sounds. Now, all the communications with Earth is performed with antennas that is connected to the communication service in the control module. Radio signals are sent to the interlinked satellite receivers, which redirects the signals back to Earth. Communications done during external activities can be done by two modules. One by using IAS, that is integrated audio system, and other by using the optical fibers connecting the backpack with the station servers directly. They can switch the mode of communication if any accidents or error occurs.
Orbit selection. Our space station next will be deployed in the lower Earth orbit. As low Earth orbit is just 400 kilometers away from the Earth's surface, the supplies, the activity of providing supplies and transfer of crew will be made easy. And it will also enable proper communication between space station and Earth. The mission schedule. Our mission will begin with the launch of the CM01, the controlling module, to the lower Earth orbit, as the module will be launched from Earth by using the Falcon Heavy rocket from the station. And all the modules are pressurized cabins. And the building of the space station next will be divided into stages. Stage 1 will be the launch of CM01. And this launch will be followed by the launching of PDM01 module, which is the passage docking module. And it will be docked into CM01. Stage 3, 4 passage modules, PN1, PN2, PN3, will be launched one by one to the station and will dock to the PDM01. Stage 4, a space observatory telescope will be launched to the space station and will into the frontal part of the space station. This will help us in space observation. Stage 5. In stage 5, we are building the ring modular structure of our space station where the food management module, the crew quarters, and the experiment modules will be provided. Stage 6. Stage 6 is the expansion of our space station. We will be sending a docking node and will be docking it to the passage docking module. Then we'll send the two integrated truss. The integrated truss P01 and S01. These are the two integrated truss that will carry all the solar panels and the energy providing system of our space station. Then is the stage where we send the crew members. A crew of 6 members is sent to the space station. As soon as the crew enters the space station, the initiation, the expansion will be initiated and will start the building up of the space tourism section of our space station. Station building. This is the flowchart of our station building. First, the launching of controlling module. Second, the launch of space observatory telescope. Third, the passage modules will be launched and docked into the controlling module. Now, the docking of circular loop structure. Here, we are making the ring module structure of our space station. Here, we'll have the passage nodes, the crew quarters, food management module, and the experiment modules. Then we'll have the launching of docking port. Now the flowchart of docking port. The flowchart of building of the space tourism. For building the space tourism, it will be initiated by the crew members only. They'll displace the truss from the docking port and the important modules for setting up of the space station will be sent each by each and will be docked, and after the creation the space truss will again be attached to the space tourism module with separating with airlock cap. This is the model of our final space station.
Now about the docking system. NICS is equipped with international docking system which provides uniformity and easy detachability during emergencies. The docking ports in the service station follows a system which allows most of the existing satellites to dock for servicing and refueling. The docking system is made of mainly two systems, the hard catch system and the soft catch system. The hard catch system on the incoming satellites has linear actuators. Suppose this is a satellite and this is incoming this is a space station and this is incoming satellite. This satellite is equipped with an capture system which has a ring which contains linear actuators. It can adjust its length and align with the soft ring on the station during docking. The elastomeric seal will seal the docking system. Next, now about the rendezvous point that we use here. Next is built in 14 rocket missions. The estimated mass of this station is almost 12,59,175 kilograms and has a speed of almost 48,280.32 kilometers per hour. We can calculate the trajectory and the rendezvous points with the help of the AI system, which is integrated into the navigation servers of the control module. Now about space manufacturing. NICS has the ability to create equipments for different purposes in the station itself. D-shaped 3D printers, which are actually working in space, are placed on the servicing module and is used to create these important equipments. The furniture for the tourist wing can be created here. Only the raw materials required for this will be brought from Earth to the space station during resupply missions. Optical fiber for the communications of during external activities will be also made using these materials brought from Earth.
Spacecraft servicing. The space station is equipped with a service module that in its initial design so that technological upgradation, refueling of satellites or spacecraft, and on-orbit servicing are possible in space station. The service module has all the necessary tools and spare parts that require for on-orbit services of satellites or spacecraft and technical upgradation of the space station and on-orbit satellites. The spacecrafts that require servicing are docked to the servicing module so that astronauts can move out of the space station and repair them with their own hands. Space tourism. The space station is designed in such a way that it can accommodate space tourism, which grants tourists the ability to be astronauts and experience space travel for recreational, leisure, or business purposes. The current design of the space station can accommodate 6 tourists at a single time. Space tourism has the potential to boost space research by leaps and bounds. It will inevitably lead to the creation of a new industry which will result in enormous benefits for humanity in the fields of science and economy. Microgravity experiments. As discussed earlier, a space station is a place where we do experiments related to space, which require a less amount of gravity. Like we cannot do these experiments in Earth. Some of the major topics that are experimented currently are material science and material engineering, fluid physics, combustion science, and space biology. These advancement in these areas lead up to breakthroughs in different varieties. Like we can find a new species by the use of space biology, and we can find effective ways to use fossil fuels by the use of combustion science.